Hey, welcome back. This is Professor Roldan with Explorations in Math, Chapter 10.3. This is our third section in Chapter 10, Compound Interest, where last time we looked at simple interest. All right, so let's get a few terms out the way as we look into the study of compound interest. So first of all, we have the concept of investment. So far we've been looking at loans, and that is the banks making money by charging consumers an interest charge for borrowing their money. Okay, so this is the other way around. This is you giving a bank your money so that you can make some money. Okay, so this is kind of the other way around. And so an investment is the use of money, or in business we call it capital, for income or profit. Okay, just depending on the situation. Now, fixed investment versus a variable investment. A fixed investment is basically guaranteed. And that guarantee is going to be with a fixed interest rate. Okay, it's not going to be variable. It's not going to change. It's a fixed rate. And a lot of the most examples from that category will be savings in a bank, money market, CDs, etc. Okay, government savings bonds, stuff like that. And CDs stands for Certificate of Deposit. Okay. Okay, so a variable investment, there is nothing guaranteed. Okay, and if nothing's guaranteed, that means interest could fluctuate, or you can even have negative interest, just depending on how the risk is. You could have no return on your investment. So this examples of this would be things like stocks. That's why you have to know what you're doing. Mutual funds, where you pay someone else to deal with that in different groups of stocks and whatnot. You have a mutual fund manager. And commercial bonds, okay, etc. So those are the different types of investments out there. And there's many more, but those are just some examples. So let's go to compound interest versus simple interest. So in the last study in 10.2, we studied how simple interest is basically, it's calculated once for the period of a loan, or investment. Okay, and the formula for this that we saw was I equals PRT. Interest charged is equal to the principal times the rate of interest times the time. Okay, so this is done over the entire amount for the entire time. just once for the period. So it's per year. So you could have 5 years or whatnot. Compound interest, however, this is calculated periodically. And what we mean by periodically is that it could be calculated once a year, just like the simple interest, or it could be 2 times a year for semi-annual. It could be daily. It could be quarterly, which is 4 times a year. Semi-annually, monthly, etc. Okay? So that's what we mean by periodically. It could occur more than once a year. Okay? And what's great about this is that the interest is compounded. And what that means is that you're going to be making interest off the interest. So this adds interest to the principal for another calculation. And you're going to see some examples in a minute. So the concept of interest upon interest upon interest has this snowball effect, or what we call compound effect. It compounds and compounds, okay? It grows and grows and grows. So the interest varies, it changes, it grows every time the calculation occurs. Okay, we're going to... you're not going to really have this, but just to be informed, the APY, or the annual percentage yield, is also called effective annual yield. Okay? And this effective annual yield is basically, you'll see this in advertisements and whatnot. It's just the simple interest rate that gives the same amount of interest as a compound rate over the same period of time. So it's the simple interest rate that gives the same amount of interest as a compound rate over the same period of time. So for example, let's say you have 4% compounded semi-annually. That's going to be the same as 4.04% simple interest. So it takes more simple interest to equal the compound interest. Okay, the compound is more powerful, therefore you need less of the interest rate to equal the same amount as a simple interest. That's just for your information, so you are educated on that. You can read more about that in the book, okay? Now, what is the formula for compound interest? Well, it looks something like this. Okay, so what this is saying is A equals P times the quantity 1 plus R over N raised to the N times T power. Okay, so what do all these letters mean? Well, first of all, A is basically the amount that accumulates. It's an accumulation of money or of numbers. Okay? It's the amount that accumulates. This is the total amount in your account. All right? And then P would be the principal, as usual. This is the amount that you're investing. Then you have R, which is the annual rate. And then N equals the number of compounding periods per year. Okay, like I said, if it's semi-annual, it's twice a year. If it's quarterly, it's 4 times a year. If it's monthly, it's 12 times a year. If it's daily, it's 365 days a year. Or 360 for the banker's rule. Okay? So, what if we wanted to know how much we need to invest in order to reach a goal in the future? So remember, A is a future amount. It's like A is saying, if I invest a certain amount now and I use a certain rate with a number of compounds, and so for 5, 10, 20 years, how much am I going to have in my account? Well, the present value formula is basically, if I want to have a goal of, say, 10,000, or I want to have enough to buy a car or a house or a down payment, how much do I need to invest now with these conditions in order to reach my goal? So that's called the present value formula, and that is basically if, so this is one formula, and if I rearrange this, in other words, if I solve for P and I get this whole big thing here, and I divide both sides by that, all this is going to go right under this A. And it's going to look like this. The P is by itself. You have the A sitting there, and then you have that big chunk in the bottom. Okay? So this is called the present value formula. It just depends if you want to know the amount you need to invest now or the amount that you want to get in the future. Just depends on the situation. Okay, so before we discuss numbers 20 and 38 in the text, I want to go over, continue the discussion from class. So this is what we were discussing in class. Basically, the difference between simple and compound interest. So the amount that accumulates for simple interest is just 5%. Let's say this is an example. 5% of 1,000 is $50 every year. Okay, that's just, yeah, your account grows, but it grows the same amount every year. So this is going to be $11.50, and this is $200. Another 50 to that would be $12.50. Okay, and then I asked you guys to find the shortcut formula. Instead of adding 50 plus 50 plus 50 plus 50, well, we can just multiply the time. Okay, So this $1,000 times 5%, there's your 50, and then your 50 times 5, okay, that's 250. So the account is going to grow by 250, which means I need to put 250 plus what I invested in the beginning of the 5 years, and of course that's going to equal 1250. Okay. So as you can see, this 1250 matches this 1250. So this is the shortcut. So this formula here is the shortcut for a simple interest scenario where you get the same amount every single year. There's no accumulation. You get 5%. You get 5% of the 1,000 year after year after year, and you end up with $250 extra after 5 years. However, in account two, we are accumulating. It's compounding. So, yeah, the first year is $50, but now I have $10.50 in the account. So now it's 5% of $10.50. So now my $10.50 grow. Instead of having $50 added, I have $52.50. So we're going to add that into my account. My account is growing. Now I'll take 5% of my growth, and you can see my interest is growing as well. So we have $11.57.63. Now we're going to take 5% of that amount. And that's $57.88. And I'm going to write this in blue. And the blue just represents the additional things we did from class. Then I'm gonna add the 57.88 plus 11.57.63. I'm gonna get 12.15.51. 5% of that. $60.78. So $60.78 plus 121.15.51. 1276.29. Okay. So 1276.29. So my shortcut formula, which is the compound interest formula, there's my 5 years, there's my 5%, there's my $1,000. Now this is only happening once a year, so the number of compounding periods is only once a year. There's my 2 ones. So basically I have 1.05 raised to the 5th power. So 1,000 parentheses 1.05 close parentheses, raise it to the 5th power equals, and I get 1276.28. Okay, which is only off by a penny. It's because we've been rounding. Okay, so notice that we have our shortcut formula right here. Instead of doing all of this year after year after year, we can say, okay, which year do you want? You want 5 years? Great. We use this formula. We put the 5 and the 0.05 and the 1, and we get the same thing. Okay, so then I asked you guys to do different years. So we have the shortcut formulas here. So notice the difference between after 10 years, okay? $1,000. You didn't put anything else in. You're just letting it sit there, using interest and time to make you some money. So far, on the left side, we have simple interest. After 10 years, we've earned $500. For the compound interest, we have earned, as you can see, $628.89, which is more and better. Okay, let's see the difference between after 20 years. So $1,000 simple interest. So just multiply by 20. And that's going to equal $1,000 interest earned. So the total amount in the account is going to be $1,000 you started with, the $1,000 that you've earned, which is $2,000. Okay. And then over here, we have compound interest. One times 20. So basically this is 1,000 times 1.05 raised to the 20th power. And we're going to get 1,000 parentheses 1.05 close parentheses raised to the 20th power. Enter. And I get 26.53 and 30 cents. Okay. So as you can see, we've made much more money after 20 years in compound interest than we did in the simple interest, okay, with those two amounts. Okay, so for part D, I'm going to talk about this in class again, since we didn't really have time for part D. Okay, so you'll see this again to see what the differences are between quarterly and monthly in a compounded interest scenario. So let's go see some real life examples here. So let's talk about page 589, number 20. Okay, so page 589, number 20. It's contest winnings. Mary wins $2,500 in a singing contest and invest the money in a 4-year CD or certificate of deposit from the bank that pays 3% interest compounded monthly. And usually that means you cannot touch the money for 4 years. And how much money will Mary receive when she redeems the CD at the end of the 4 years? Alright, so let's write down some key information as we come across it in the problem. So, $2,500, that's the amount that she's going to invest. That's P. And it's so it invests in a 4 years CD. %3 interest, so that's the rate. I'm going to go ahead and change that to 0.03. And this is compounded monthly. So that means that's 12 times per year. Okay, so we're going to n is actually equal to 12. All right. So let's go ahead and plug this in. So it's going to be P 1 plus R over N raised to the N times T power. Okay, so we got our P, which is 2,500. The rate is 0.03. The number of compounding is going to be 12 in a year, so it's going to be divided by 12. and then that's going to be 12 times 4 years. Okay. Okay, so I highly recommend that you don't type all this all at once in your calculator. You can, but I recommend you simplify a little bit. So I would type in this part in your calculator. Okay, and if you type 0.03 divided by 12 plus 1, without rounding, is going to be 1.0025. Okay, and then 4 times 12, you can put that in your calculator, and that's going to be 48. So this is what I will put in calculator. All at once. So you type all that in, 2500, close parentheses, 1.0025, close parentheses, raised to the 48th power. Okay, you need to learn how to do that on your calculator. That's going to give us 2,818 and 32 cents. If you round somewhere along the process, you will not get this exact cents, and my math lab will tell you that it's wrong. Okay, so no rounding. In this part right here. Okay, if you round it, you're going to be off by a little bit. Okay, so this is compound interest. Now, how much would she have made, Mary, if she would have had this in a simple interest account? So let's just for fun compare to simple interest. Okay, so for a simple interest scenario, it's just going to be 2,500 times 0.03 times 4 years. And if you type this in, you're going to get $300. Okay. So how much did she make over here? If you subtract the 2,500, she actually made $318.32. So as you can see, this one's better. Okay, compound interest is definitely better than simple interest. Okay, let's take a look at page 590, number 38. And it says, this is about a new roof. Rebecca will need to replace the roof of her house in 5 years. How much should Rebecca invest now in a money market account that pays 2.1% interest compounded quarterly in order to have $6,000 in 5 years so she could buy a new roof? Well, let's go ahead and write the information down as we come across it. And so the goal is to have, in 5 years, have enough money to buy a new roof. So how much should Rebecca invest now? So the investment or the principal is what we don't know. How much she should invest now with a rate of 2.1%, which is 0.021, compounded quarterly, which is 4 times a year. So we need 4 in order to have $6,000 in the account. So A is going to equal $6,000. Okay, so you got to be careful with the terminology. This one was what's the account going to turn into if you invest $2,500 now? What is it going to turn into later? Over here is, what do we need now? What do we need now in order to get this later? Okay, so that's the A. So basically, you're going to use a present value formula, which is the one right above the notes right here. So P equals A over the 2 parentheses. So P is going to equal 6,000, 1 plus 0.021, and we're going to divide that by 4. And 4 is going to go here for the N, and the time is 5 years. Okay, all this information I'm getting from all these spots here. Okay. So again, I would simplify the bottom part as much as I can, or the parentheses. So that's going to be 1.00525, and then 4 times 5 is 20. Okay, and then this part is the one you want to type in your calculator. Type this in, and we're going to get 5,403 and 43 cents. Okay. So if you invest $5,403.43 in that account, which doesn't really pay a lot, then you'll make the other $600 or so you need to make the 6,000. Okay. Okay, so now I'd like to do a couple problems from the textbook. Okay. And I would like to do, I would like to do number 13. Okay. So number 13 says, all right, so this is not a word problem, just gives you all the info all at once. So $8,000 for 2 years at 4% compounded daily. Use N equals 360. That's the banker's rule. So basically we have the P, we have the T, we have the R, we have the N. Now this one's daily. Okay. So how many times does this happen in the year? 360 times per year. So that we're going to use that number. And of course we're going to find what the account is going to equal. Alright, so we have everything we need. We just plug in everything in and see what we get. 1 plus 0.04 divided by 360. 360 times 2 years. $8,000 plus, and we're going to put, let's see here, 0.04 divided by 360 plus 1. So this one goes on forever. And we're going to have to round it, unfortunately. Let's see what difference that makes. Let's see, 5 decimal places. Let's see. Let's see what happens when you round it. Okay, just as an illustration. So 360 times 2, 720. So 8,000 times 1.00011 raised to the 720 power. Press enter and we get 8,659.33. Okay, now versus no rounding. So we're going to type all this into the calculator. So 8,000 parentheses 1 plus 0.04 divided by 360 close parentheses, raise it to the parentheses. Well, we know that's 720, so I'm just going to put 720. And definitely it's a big difference here. Okay, so as you can see, if this thing goes on forever and you have to round it, we're going to have to redo it so that it doesn't, so you don't have to round. Okay, because you can see there's a big difference between these two answers. Okay. Okay, I wanted to also take a look at 19. And 19 is about an inheritance. Marcus received an inheritance of $6,500. He decides to invest his money in a 5-year certificate of deposit CD that pays 1.86% interest compounded semi-annually. How much money will Marcus receive when he redeems the CD at the end of 5 years? So guys, it's clear that the money is being invested now, and you want to know what will it look like later, okay, in 5 years. So we are going to be missing the A, as usual. So So 6,500. Sorry. 5 years. 1.86%, which is 0.0186. And it's compounded semi-annually. Okay, so semi-annually is semi meaning 2. So there's our N. All right, so we want to know how much is in the account. Okay, so why don't you try this one on your own and see what you get. So pause the video and check your answer in a few minutes. All right, let's see how you did. I got 7,130 and 44 cents. So again, this one did stop at 4 decimal places, so I did not round, even though it kind of looks like it. This didn't go forever, so I just wrote down everything in here. Okay. But you probably want to get used to typing all this at once. Some of your calculators can't really handle that, so I'm trying to offer an alternative to this part right here. Okay, so one more on your own to see how you do with present value, and this is going to be for number 37. So number 37 says, Adam wishes to have $20,000 available in 18 years to purchase a new car for his son as a gift for his high school graduation. To accomplish this goal, how much should Adam invest now in a CD that pays 1.55% interest compounded quarterly? Okay, so let's get the information down. So wishes to have $20,000 in 18 years. So this is a future amount. So A is going to equal 20,000. Okay, that's the accumulated amount after 20 years or 18 years. So this is the goal. How much should Adam invest now? So that is how much should be the principal for this investment for a CD that pays 1.55%, which is 0.0155. And this is compounded quarterly. So that means 4 times a year. Okay. So let's put this all together. We have the A, so we're going to use the P formula. Whoops. Okay, so go ahead and stop the video, plug in everything, and see how you do. Okay, let's see how you did. $15,138.96. So if your calculator can handle it, then you can just type all this in. Let me know if you need help with that. If not, this happened to stop right here. So I was able to just type all this in into an easier format. But again, if this goes on forever, or if it doesn't fit in your calculator, you're going to have to leave it like this, okay? Just going to have to play with your calculator, the one you're going to use for the test, and see how you do. Let me know if you need any help with that, okay? All right, guys, that's it for 10.3, and we'll see you in the next video.